All right. So in this module, I want to talk a little bit about what we call the Arrhenius plot. And so this has to do with the expression for the equilibrium number that we've just talked about here in the fractional form. So nv over n is equal to that exponential. So the Arrhenius plot is actually a way we use to get the activation energy QV. So from experiment, we can determine this. And what we would do in that experiment is try to determine the number of vacancies as a function of temperature, and then use that to determine this activation energy. However, we see that this expression is exponential, right? So if we plot that, so if we plot NV over N as a function of temperature, we get this exponential dependent. And we could fit this with an exponential fit, but it's customary and easier for us to linear fit something. And so instead, we do what's called an Arrhenius plot. And that's when we basically rearrange this, if you think about it, take the natural log of both sides, and that would allow us to plot the natural log of that fraction versus 1 over the temperature. And in that case, this linearizes this expression over here, and the slope is going to be related to Q in K. So we can fit this linear function and get the slope, and that allows us to determine the activation energy QV. So an Arrhenius plot is very common for this type when we see vacancies, but also more importantly, in really the entire field of materials, we find this exponential of a temperature function pretty much almost everywhere. And so it's not uncommon to see an Arrhenius type plot where you're doing the sort of natural log of this plotted against 1 over t, which is known as the Arrhenius plot. It's not uncommon to see that because it linearizes the data and allows us to determine this thermodynamic activation energy QV or whatever else it is. So it's not just the number of defects. There's a lot of other relationships in material science that follow this Arrhenius type, and it's very common in that. And so that's why I wanted to spend a second to talk about that. So if you ever see this kind of thing, this is an Arrhenius plot, and this kind of Arrhenius equation is just referring to the linearization of an exponential for that reason.